Okay, so today we're going to be talking about the different types of mutations that we can see occur during transcription. So the first type that I want you to focus on is on point mutation. So the way I remember this one is how many fingers do you point with? One finger. So when I look at point mutation, I see that only one nitrogen base is being switched out. So point mutation is when one nitrogen base, in this case G, is replaced by another nitrogen base, C. Now, point mutations are sometimes referred to as base substitutions. So you need to know both. Point mutation and substitution are referring to the same thing. Now, when we look at point mutation and we're looking at, okay, this is the effect that we had in DNA, what would be the effect when we look at our protein? Point mutation, since it's only changing one base, only one amino acid is affected. So I want you to look at the example here. In the example, I have the cat ran far, as you can see here on top. Now, when we have a point mutation, it says the bat ran far. So in here, I see that only one word is affected, just like only one amino acid is affected. And the reason why only one word is affected is only because one letter has been changed from C in cat to B for bat. Now, when we look at the second type of mutations, is called a frame shift. So a reading frame is every 3 bases, which is why in my examples that I am giving you 3-letter words. So in frame shift mutation, there are 2 major types. The first one, which is insertion, and the second one, which is deletion. So for the first example, when we look at insertion, insertion, just like it says, is when one or more nitrogen bases is added to the DNA sequence. So when I'm adding nitrogen bases into the sequence, you can see that the entire sequence is then pushed down. So this shifts the reading frame down. So when I'm reading every 3 bases, all of my amino acids that occur after the mutation will be affected. So in the example here, we have the cat ran far. Now, since this is insertion, I inserted a P here. Now you can see that all of the words that come after this P are affected. So that means that 1, 2, 3, 4, all the ones continuing down, all of those amino acids would be affected, meaning that we would have a mutation in the entire sequence. So the amino acids before the substitution or the insertion are okay. All the amino acids after are the ones that are affected. Now, when we look at deletion, just like the name is saying, it is when one or more nitrogen bases is deleted. So you see here, so then my DNA sequence actually gets smaller. So then everything is shifted up. So as you can see here, just like insertion, deletion, here I deleted the C. So I had the cat ran far, and over here you can't understand these last words because I've deleted the C. So when I deleted it, everything moved up. Now, with the same token, everything after my deletion is affected, just like everything after my insertion is affected. So when I look at the difference between a point mutation and a frame shift mutation would be worse off because it is affecting more amino acids than a point mutation would. Now, the fourth type of mutation is called inversion. As you can see in the picture that you see here below, I want you to focus on the purple and on the gray. Now you see here that the purple has been switched with the gray. So inversion is not inserting a base or deleting, and it's not substituting, but yet 2 nitrogen bases on the DNA sequence have been flipped or inverted with each other. So an inversion mutation is when one nitrogen base is switched or inverted with another one, as you see here between the purple and the gray. Now in this case, only 2 amino acids are affected since only 2 nitrogen bases are being switched. So when you look at the example, we see that our original sequence says the cat ran far. Now you see that I have 2 different words. The rat ran fac. So when you see here, the C from cat and the R from rat and from far have been switched with each other. Now, I just wanted to show you another example of substitution, insertion, and deletion, but more from the aspect of what is changing in how many amino acids. So we know that a substitution is just the same thing as a point mutation. So you can see here that in my original one I had a G, but here I have an A. So when I look at the amino acids, only one amino acid is affected because I'm only changing one base. Now in the insertion, I'm inserting this base here. So you can see that I am inserting another C, so then everything has been shifted down. So you see this CTT that I have at the top. I see CT, and then the other T has then been shifted down to another reading frame since I read every 3 bases. So you can see that after the insertion, every amino acid after that is going to be affected. Now with deletion, you can see that I had 4 A's in my original sequence, but now I only have 3 because one of them was taken out. So then everything has to shift up. So as I begin to read my messenger RNA, you notice that all of the amino acids that come after the deletion are affected, just like every amino acid that came after the insertion. So when I look to see which type of mutation is worse, insertion and deletions both affect all the amino acids after their mutation. But in substitution or point mutation, only one of the amino acids is affected.